Please welcome the Vice President of Search, Observability, and Cloud Ops at AWS, Nandini Ramani.
Hello, everyone, and welcome to what is the kickoff of reInvent 2024 with our very first innovation talk. The last 12 months have been super exciting for us here at AWS with lots of new advancements, lots of new innovations, and we can hardly wait to share that with all of you. As many of you are aware, at AWS, 90% of our roadmap is driven by customers such as yourselves. And I personally love my conversations with customers, and it's through these conversations that I gain insights into your needs and what you need in order to operate successfully in the cloud. And I want you to leave this talk today knowing that no matter what industry all of you are in, AWS is building the future of cloud operations, a unified experience that every SRE, IT operator, DevOps engineer, cloud architect, and application developer can benefit from. A unified experience that removes the undifferentiated heavy lifting for you so you can focus on your business while we let you operate at scale on AWS. Excuse me. And it's a combination of these three things that you see behind me that truly guides us, our roadmap, and it drives us to keep innovating on your behalf. One, AWS has more experience than any other major cloud provider. And that translates into an excellent foundation upon which you can operate at scale in the cloud. And two, over the past 17 years, we ourselves have been operating AWS, and we have learned a lot from doing so. And these learnings is what guides how we actually continuously improve our services, the features that we launch, and the guidance that we provide to you. And third, most importantly, we continue to listen very closely to our customers. A question that I often ask my customers, and in fact, I stood last year on the same innovation talk stage and asked the very same question. And in general, the answer to this question of what challenges keep you up at night operating in the cloud, they fall into three general themes. One, you want your operations to be able to scale as your business scales without you having to do anything unnatural. Second, you want to gather insights from all the data that's being produced from your environment, and you want to be able to gather insights no matter where your data resides. And third, you want all of this with built-in automation and controls. Now, none of this is easy, and we at AWS are working hard to help you with these challenges. Now, the key idea to solving these challenges is we want to connect our services more harmoniously, more seamlessly, so that you do not have to stitch things together in order to make the information come together. Now, instead of using a quote from the 4th century BC, we thought it would be more fun to have a theme that's more modern and contemporary. And so in order to help me illustrate this concept, which you're going to see throughout this talk, I'd like to invite a very tenured Amazonian, a senior principal technologist on my team, David Janacek, to the stage, and he will explain to you the theme that we're going to be using. David? Welcome.
Thanks, Nandini. When I was a kid, I used to watch shows with robots. And each of these robots had some unique skill or ability. And when these robots merged together, they formed some more powerful form with more capabilities. And I think it's fun to think of AWS Cloud Operations Services in this way. For example, for observability, we have CloudWatch metrics. And metrics is good at measuring your performance over time and visualizing that. So we could call that metrics bot. Or when I need to fix something in my AWS environment, I can use AWS Systems Manager. So I'll call that action bot. Or AWS config is really good about scanning across all of my AWS resources to make sure that they're configured consistently and correctly. So that's inventory bot. But when these CloudOps services combine, these CloudOps bots combine, they take on a more powerful form known as Opsitron. Opsitron is a formation of all of these and takes on different forms depending on which CloudOps bots are joining together at the time. For example, you can write CloudWatch logs and configure that to extract CloudWatch metrics and then alarm on anomalies in those metrics. So that would be a fusion of the logs bot, the metrics bot, and the alarms bot to form its own Opsitron. This one on the back of my t-shirt. So throughout this talk, you're going to hear a theme of new capabilities of AWS CloudOps services that are around bringing features together to make them even more powerful than if you were to use those features independently. So I'll be in and out during this talk to give you some demos and show you some of the more recent observability-related Opsitrons. So I'll see you in a bit.
Thank you, David. So I don't know about all of you, but I'm certainly very excited for this theme of Opsitron. So I want to break the rest of this talk into three pillars, the trifecta, if you will, of what it takes to transform how you operate in the cloud. The first, which is very foundational, is governance. How do you set up the controls for your environment? Second, observability, so you can gather telemetry from all of your resources. And third, analytics, so you can gather insights from all of the telemetry that you have collected. So let's begin with the first pillar, which is governance. So in order to have a strong governance posture, it is super important for you to have the right set of tools and the right governance frameworks. You have told us that you need consistent visibility into all of your resources across resources on AWS, for example, EC2 instances, resources that are running on your hybrid servers, and in some cases, multi-cloud environment. Second, you want to be able to manage drift, which means once you set up your policies, you want to ensure that they stay in place even as your environment changes with either new users, accounts, or resources. And third, once again, you want automation in order to make it easy. In order to provide you with consistent visibility, I am excited to announce we are launching a new feature in a service that most of you are familiar with, AWS Systems Manager. With this launch, you no longer need to manage your nodes, which typically in most cases is like hundreds of thousands of nodes, account by account or region by region. Instead, with this new unified experience, you can more easily manage all your nodes no matter where they're running, on AWS, on-prem, or in a multi-cloud environment. And from this new dashboard that you can see in Systems Manager, you can also see all of your managed nodes, as well as those nodes that are not being managed, all across your AWS accounts and regions. And from this dashboard, you can also remediate any of your unmanaged nodes. You can also zoom in and explore each of these nodes in more detail, and you can filter them either by operating system type or agent versions, etc. And what's more, we're integrating Systems Manager with Amazon Q Developer, thereby extending your ability to see and control all your nodes from anywhere on the AWS console. For example, you can simply ask Amazon Q Developer, find me all the nodes of a specific OS type, and it will show you the answer to those questions. And if you haven't, I highly encourage you to kick the tires on Amazon Q Developer. My teams love it. So one of the key asks that we get from customers as it relates to a strong governance posture is, how do I prevent unintended actions or non-compliant actions in my environment? And in order to address this, we're launching 2 new preventative controls. The first one, declarative policies, which gives you the ability to prevent non-compliant nodes in your environment by simply declaring the configuration that you want for a particular AWS service. For example, you can set a policy that says, I want to block all access to VPCs across a particular organization within your group. And once set, this declarative policy will always maintain the configuration that you set, even as your environment changes. I alluded to that earlier, so there's no drift. And what's more important, this stays in place even when an AWS service launches new APIs. The second preventative control is RCPs, or resource control policies. Resource control policies basically give you control so you can set the maximum allowable permissions that are available to any resources within your organization. And in this way, you can restrict any unwanted access and unintended actions on any of your resources. Both RCPs as well as declarative policies are available for use in AWS Control Tower as well as AWS organizations. And you can either choose to use them independently, or for those of you who are already using service control policies, you can use it together with service control policies for a stronger governance posture. Now, at AWS, we really like to tell our stories through the voice of a customer. So let's hear from a customer on how they are leveraging AWS in order to have a strong governance posture in the cloud. Please welcome Parvez Naqvi, Managing Vice President of Resilience and Reliability Engineering from Capital One. Welcome, Parvez.
Thank you, Nandini. Hello, all. Hope you had a great weekend celebrating Thanksgiving with your friends and family, and are excited to be here. I know I am. Like Nandini said, I lead resilience and reliability engineering for Capital One. For the international attendees, Capital One is one of the large US financial institutions. We offer traditional services like banking, credit card, auto finance, and many more to over 100 million customers. In 2016, we made a very bold declaration. We said we will be a cloud-first organization. Within 4 years, in 2020, we had exited all our data centers. This image that you see is very, very near and dear to my heart. It's an actual data center which was being decommissioned. And it was because of tremendous amount of work which was done in collaboration with our team, partnering very closely with the AWS team. In the last 5 years, we have learned a lot. I'm here today to share a couple of learnings with all of you, some things which we think were very helpful. Using CloudWatch, CloudTrail, and Config, we were able to build and manage very complex infrastructure. This, in return, was helping us with resiliency, cost management, and now overall governance. To put some numbers here, in the last 5 years, number of incidents which impact our customers reduced by 75%. In the same time frame, our cumulative cost or cost efficiencies improved by 70%. What was really interesting was not just these two numbers, but we used the same technology and the same data to manage governance for us, to answer various questions, to audit and other things. We were early adopters of service control policies. Nandini just talked about resource control policies. We were part of the beta earlier this year, actually trying this out. We use these types of services to restrict access to our very, very large infrastructure. So how did we get to this well-managed state? To understand that, let's spend a few minutes to get the background of what our infrastructure looks like. Our universe in cloud looks like this, yes. We have tens of millions of objects or resources which are actively working as I speak right now. Now, to better manage this infrastructure and to reduce complexity, we divided this across thousands of accounts. The benefit of having thousands of accounts was we were able to restrict the blast radius of our systems, and also the management became easier. The secondary thing was we have tens of thousands of security policies, including IAM policies, service control policies, and resource control policies. Again, it looks like very big, tens of millions, but with all of these things, it becomes a little more manageable. Let's zoom in a little. This is what it really looks like. As the adoption of serverless has grown, the creation and deletion of resources continuously go up. Now, I started talking maybe a couple minutes ago. Few thousand resources were created and deleted literally in these few minutes. Now, in this large universe running a system of this complexity, if I said we operate with 4-9 availability, some might say great, some will say no, we should have 5 nines and great. You know, these are all technical words, technical numbers. Let's talk from a customer's point of view for a second. If you are buying a house and in the morning your escrow company calls you and says, your wire transfer never came through. Now, I could come back and say, no, listen, you were part of that 0.001% transactions which failed. You could care less, like a very important transaction which was important for you did not work. For us as a bank, failure is not an option. To manage a system of this complexity, I think from observability point of view, there are two main problems that I personally worry about. One is unknown unknowns, and the second is known unknowns. So let's spend a minute to understand what these two things are. A known unknown is something where I know about a resource, but I don't know why it is not doing what it was supposed to do. Supposed to do transactions in a certain fashion, they're failing. That's the first bucket. And the second bucket is unknown unknown, where I don't know what is that resource, I don't know where it exists, is just non-existent from my dashboard. These are the zombie objects. We have petabytes of data in CloudWatch. With that data, along with million-plus alarms, we have solved the known unknown problem very successfully. If there is something running and I have some information about it, I can get to the root cause to understand why that specific resource is not doing what it is supposed to do. But in reliability, there is a foundational principle that we can't act on what we cannot see. That brings me back to those zombie objects or zombie resources. When I don't know those resources exist, I cannot actually put any engineering behind it to actually solve this problem. And that is a classic gap in visibility for us. Using CloudTrail and config, we were able to bring in real time information to our backend system, which basically helped close up blind spots. These blind spots were helping cover for all these unknown unknowns or these zombie resources. Together with CloudWatch, CloudTrail, and config, our system has become a lot more intelligent than where we started. Instead of walking you through this data flow diagram, let's take an actual use case, which probably will make sense, and this is what we deal with. In resiliency, I think of detecting failures as the singular most difficult thing that we deal with. It's a dependency is having an issue, or its dependency is having an issue. How do you isolate the problem? For example, bill pay service is having partial failures here. Very quickly, you can understand that the first two steps are fine. It's the print check API which is having an issue. Print check API has a database dependency, which is accessed through this update database API. The database API is working just fine. Somehow, there is something missing in that whole connectivity. When you bring data from CloudWatch CloudTrail, and config together, you can understand your infrastructure and software dependencies very, very quickly. In this example, you will be able to drill in with real-time data that there is an instance in update API which is misbehaving, which is why you are seeing partial failures and not complete blackout of a service. Identifying root causes like this becomes a lot easier with CloudWatch, CloudTrail, and Cloud Config with some of our systems. Closing this, we believe innovation is very critical for all companies. Innovation has to be at the speed of well-managed, especially when you're in cloud, which means security, cloud management, resilience, and governance all have to be thought about at the time of system design to help ensure your critical transactions, your wire transfers, succeed every single time. Before I close, I want to highlight the collaboration we have had with AWS over the last few years. We have jointly worked on solving some really complex problems, fun problems. But before I leave, I want you to visit this link. This is where Capital One shares some of the fun things we are doing in technology, some of the innovative ideas we are working on. Hopefully, you'll enjoy those. Thank you.
Thank you, Parvez. It's always fun. I really enjoy hearing about how customers are using our services. So now let's keep going. Part 2, observability. At AWS, we strongly believe you cannot manage what you cannot measure. And to operate efficiently in the cloud, you need to think about observability more proactively rather than reactively, which is understandable. Otherwise, you're flying blind when anything is down or your auto-scaling isn't working, et cetera. So we built and we use CloudWatch, our flagship observability product, service, for our own internal needs. This is true for both Amazon as well as AWS. In fact, you can find our teams poring over dashboards, CloudWatch dashboards, in order to troubleshoot and lower our own MTTR. In 2019, counting only external usage, CloudWatch was used to monitor 1 quadrillion metric observations per month. This number grew to 9 quadrillion in 2022. And today, CloudWatch monitors more than 20 quadrillion metric observations per month. That's 20 followed by 15 zeros. Now, while we're arguably happy with the scale and this growth, however, storing and presenting a quadrillion metrics is not in and itself helpful in any sort of way. What you need to be able to do is what I referred to earlier. You want to be able to connect all of this telemetry. You want to do this no matter where your data resides, and you want to be able to take actions that will help you remediate should you need it. So to address some of these challenges, we have a lot of new features in CloudWatch. And rather than me just talking about it, I'd like to bring David back on stage to use the Opsitron analogy and show us some demonstration of these features in CloudWatch. Take it away, David.
So now I'm going to show you some new forms of observability Opsitrons. These are a couple of newer features that are designed to bring together the ability to explore and navigate across your infrastructure and application architecture. So let's say you're on call for the robot service. The robot service is something that customers use. It's a made-up thing, but customers use it to provision and instruct their robots, send them instructions. But something happened. Something's broken now. Thankfully, CloudWatch Alarms, aka AlarmBot, was watching my metrics, noticed an anomaly, and it paged me. So here I am, the on-call. I've started here on the alarms page, but I need to know where to go to start my investigation. So I'll scroll down to where the description is. Now, unfortunately, past me didn't do future me any favors, and I didn't fill any links to dashboards or runbooks, so I'm going to have to follow my own breadcrumbs. So I scroll back up and use the new Explore Related feature. Explore and Investigate is a side panel that follows you around the AWS console. It brings you telemetry about the AWS resource you're looking at and helps you navigate across to adjacent resources to investigate next. Already I can see and do my investigation. Think of this as actually ExploreBot. So it's actually helping me from getting lost or confused. In this case, ExploreBot started me from an alarm, which was derived from metrics, which was emitted by a load balancer. So here's all the telemetry about that load balancer that I can use to investigate. And I can rule out a few things just at a glance. I can see the traffic did not increase, so it's probably not an overload. Let's keep navigating. Load balancers have target groups, which emit their own metrics. And from those metrics, I can learn new things, like the healthy host count has stayed the same. So that means I'm not crash looping. It means I'm not reactively scaling up. So it's ruling out a couple of new other failure scenarios. I'll follow along to the EC2 instances behind the load balancer and look at their metrics. And I can see the CPU utilization and other metrics are pretty flat. No one is sticking out compared to the others. So again, ruling things out. But I need to kind of move on out of infrastructure land. I've looked at infrastructure metrics, not seeing much. Let's move into the application to see what my code is doing. So this Explore feature has noticed that those EC2 instances also have an application of mine running on it that are emitting metrics and other kinds of telemetry. So it brings that to me here too to look at. It also notices that my EC2 instances are emitting logs. So I can click over to logs, and Logs Insights, aka LogsBot, is going to run a pre-canned query that shows me just the patterns going in on my logs. I can click here and do some deeper log investigation, but this is summarizing those hundreds of thousands of log records into just a few things so I can at a glance see what's going on. Not seeing anything there, so I'm starting to think that I need to look somewhere else. So I'm going to navigate up and dive further into the application using application signals. Remember how I said that Opsitrons are formed by combining and joining other smaller robots? Well, application signals is just like that. It combines metrics, logs, traces, application topology, all together so that you can zoom in and understand what your application is doing. It's taken me to the microservice called bot service that was running on those EC2 instances that I was looking at previously. But I need to step back to see what's going on across my bot services. So I click on the services overview. Here I can see that this is all lit up. There are tons of unhealthy service level indicators. I'm seeing fault rates between different dependency paths. The automatic dashboard is showing me the same. So clearly there are problems. I need to zoom out even further just to get a sense and map where my common dependency is that's having a problem. For that, I'll use the service map in application signals. This shows me left to right, from the customer calling my service on the right to the deepest dependency all the way on the right of which is having the problem. And it overlays health information. So I can see that the bot forge service all the way on the right is the common dependency that I actually need to investigate. I was looking for a needle in the wrong haystack, so this has navigated me over. So now looking at bot forge in application signals, I can dig in and figure out why it's having a problem. If I click on the service operations button, that shows me each API of bot forge and its availability. This get API, which loads configuration about robots, is clearly having a problem. In the upper right, the faults graph is spiking, showing me that where the problem is. So I know I'm now in the right place. I know there's a problem, but I don't know why there's a problem. So I need to zoom in on those faults to break that metric down into its constituent parts to see where those are coming from. I could click on spans, but in this case, I'd want to take that metric and just break it down by things like availability zone or per instance ID. So I'll use top contributors. And this runs a logs insights query behind the scenes to show me the fault rate broken down by EC2 instance that it's running on. And so here we have it. We can see the problem. It's my application is behaving weird on just one of my EC2 instances. All of the faults are coming from just one. So all I need to do is remove that EC2 instance from service, and my customers will be happy again, and then I can take my time to investigate the root cause later.
Sorry, it took me a minute. No problem. Thank you, David. Before you go, I have a couple of questions for you on the demo that you just showed us. I did not see you typing, copying log IDs, no runbooks, so can you explain how you?
Sure. I mean, that is the real objective of these features, is about connected telemetry, so that I don't have to use my brain to remember where to look. I don't have to remember, oh, that's the log group name, or that's the dashboard I need to go to, or whatever. I just clicked. Notice I didn't use my keyboard. I didn't copy-paste anything. I didn't have to think of new tabs to open. I just followed the kind of information sent that the console was giving off and navigated.
Yep. And one other question. Was this actually just simulation? Was it production code? And most importantly, how did you get it to break?
Oh, yeah. I mean, a good demo for observability stuff showing incidents, it kind of has to be real. So I made a fresh set of microservices to talk to each other. I created this last week or something, or the week before. I needed to make it quickly, so I used Amazon Q Developer. It's the IntelliJ plugin. It wrote my CDK code for me to provision all these microservices and stamp out the infrastructure, wrote some of the code for me. It's pretty handy. To get it to break, I actually needed to make, I can't do an ops investigation without something breaking. So I injected a fault using the AWS fault injection service. That let me make my application crash on one of my EC2 instances.
Awesome. And speaking of fault injection service, for Prime Day is a classic example, right, where you need high availability. And in fact, the last Prime Day, we had record-breaking sales. And AWS helped Amazon retail teams run over 700 experiments using the fault injection simulator. And now the service also adds a new feature where it generates reports of resiliency testing, so you can provide it as evidence and you don't have to curate those sort of things. Another one I highly encourage all of you to try. Thank you so much, David. So when it comes to observability, you have told us you need visibility not only in your infrastructure, which could be on AWS or on your own on-prem other environments. You also need visibility into your network, databases, most importantly, application context. And you want the context to come out of the box so that you can navigate between logs, metrics, events, et cetera. So today I want to walk through some of the features that David demonstrated that are new capabilities in CloudWatch. So let's get started. So with all kinds of resources spread in your environment across different environments, hundreds of applications, it's sometimes difficult to navigate and stitch all of this together. Now, CloudWatch adds context to your telemetry data, as you saw in the demo, so that you can get contextual relationships amongst you. This is why he didn't have to type anything or use any runbooks, because the context automatically exists. Now, in the demo, David showed you how he triggered on a load balancer metric, introducing the fault. But this works with any AWS resource that emits metrics, which means you can start from many of the AWS services from their console as your entry point, and then you will be able to drill down all the way to the log, so you don't have to go around debugging and troubleshooting. No setup needed at all. Next, you need visibility into the health of your network, which is so important from an end user perspective. Excuse me. And the traffic flows today between source and destination resources can sometimes make this challenging. Now, we are expanding CloudWatch Network Monitoring, which is a feature we already rolled out, to cover network flows. So what does this mean? It means you can now monitor TCP traffic between AWS resources, so you can understand your network performance, including metrics such as packet loss, latency, et cetera. You can also send health events to the health dashboard, to the support dashboard, so that when an AWS issue impacts any of your workloads, that information is readily available to them, which means if you call support, they already have all of this information out of the box. This feature also helps you determine whether the problem is in the AWS infrastructure or if it's in your application, which could be impacting your end users. Next, many of you likely run multiple database instances of various sizes across both your dev and prod environments, supporting typically hundreds of applications. Until now, you needed deep database expertise, and in many cases, you probably use multiple consoles and tools. Today, we are launching Database Insights in CloudWatch, which lets you have a single view of all of your database instances and your entire fleet, so you can monitor the health of your fleet. At a glance, you can see a heat map of all your database load, and you can zoom in on any of your database instances, Aurora database instances in this case, that might be running hot. And this also, once again, works out of the box with application signals. You don't need to run an agent or a sidecar. It just is fully managed and works out of the box. Many of you run your applications using containers. Last year, we launched Enhanced Container Insights for EKS, and now CloudWatch offers Enhanced Observability for ECS in CloudWatch Container Insights. You can now drill down into container-level metrics, and you can go down into the layers of your containers to find individual containers that might have memory leaks or other issues. Now, once again, this runs without any agents, no sidecar required, just fully managed out of the box. Once again, I would like to invite a customer over who is using AWS to transform how they observe. I'm not sure how many of you are familiar. Dream11. Dream11 is India's largest fantasy sports platform with more than 220 million users. And they will share with us how they use AWS to scale their cloud operations. Please join me in welcoming Amit Garde, Senior Vice President of Engineering at Dream11. Welcome, Amit.
Thank you, Nandini, and great to be here. So let's dive right in. Dream11 is India's and the world's, actually, largest fantasy sports platform. We have more than 220 million registered users. And just to put that into perspective, that's more people than Brazil. If Dream11 was actually a country, we'd probably be the 7th most populous country in the world. And we're growing. We added the equivalent of 2 Australia's worth of users over the last year. Now, we support 12 sports on our platform, and our daily fantasy format sees more than 22,000 matches a year across all sports. Right? We offer 12 sports, right? But really, cricket is the one that matters. Right? Cricket is huge in India. Right? In fact, it's practically a religion. Right? It's like, seriously. Right? And cricket matches see an enormous amount of user interest, and that translates into a huge amount of load and traffic on our systems. Right? And this combination of, say, an IPL match. IPL is the Indian Premier League. That's one of the marquee cricket events. So everything I just said about cricket events having a huge amount of interest, take that up a level for the IPL. Right? This mix of a T20 cricket match, a massive fan base, and our daily fantasy format makes life really interesting. So before a cricket match starts, about 30 minutes before, match information starts to come out, who's won the toss, what the pitch conditions are like, the player lineups. And that's when users will start to pour into our platform. Right? They will log in, they will create teams, deposit money, search for contests, join contests. So we see a very steep ramp up in traffic. As you can see on the graph here, this is real traffic data, by the way, taken from an actual IPL match. We can literally see an increase of 2 orders of magnitude in a matter of minutes. And what these users do in these 30 minutes is really what brings in the revenue. Right? So this window is absolutely crucial from a business standpoint. Right? Any kind of unavailability or UX glitch is a huge hit. Right? And if that wasn't enough, as a cherry on top, we only get one shot to get it right. Right? Our fantasy format means that once the cricket match starts, you're done. You can't have users join contests anymore. There's nothing they can do. It's not like some other applications where if you're in a shopping cart, for example, and the checkout failed, you could sometimes at least, come back and complete the operation later. We don't have that luxury. So how do we cope? In order to be able to operate successfully in these conditions, you have to know what you're doing. And there's a lot of work that know is doing here, because you obviously need to know what to do. But in order to know what to do, you need to know what's happening in your systems and where and why. And that's observability. So observability is the bedrock, no pun intended, of successful operations. Our entire operational posture is premised on good observability. Now, we've evolved over time, so being very indexed on being able to respond very rapidly after an incident had happened, to increasingly being able to detect something emergent and intervene to preempt it. But whether it is response after the fact or preemption, you still need really good observability. Right? But observability alone will only take you so far. Right? It's kind of pointless knowing what's going wrong in your systems if you don't have the ability to do something about it. Right? So the ability to respond effectively with a meaningful intervention depends critically on automation. It's only automation that will give you the speed of response and the error-free intervention that is needed in these current situations. Right? So we target having automation, that is push-button responses, for everything we've learned, in many cases the hard way, that we will need to do, whether it's spinning up servers or shifting traffic, failing over, flipping a feature flag, shifting a configuration. And we try to anticipate some other what-if scenarios as well and have automation and pre-programmed responses for them as well. And this is like a 1,000 feet view of how we view observability. So we find it useful to model our observability needs in two pieces. The first piece is observability signals, metrics, traces, logs, spans, what have you. This is the primary data. And our objective is to get all the primary data that is relevant and useful. Those are the yellows on the diagram here. The second piece is where we make sense of that data. You translate those primary signals into an understanding of what's happening. Has something crossed a threshold? Is a metric breaching? Is there an anomaly detection? Right? Or more generally, the ability to ask arbitrary questions of your system state and have them answered quickly and correctly. That's the middle piece. A third complementary piece, and this is not observability, classically speaking, is the automation. So the signals feed into the analysis, which then leads to pushing the right automated button in order to make sure your systems are up and running. So as you can see, it flows left to right quite naturally. Right? Signals to synthesis, understanding, and then action. And this is how that mental model translates into an actual system for us. So we are predominantly an AWS shop. So you'll notice a bunch of AWS services show up here and in the previous slide. We get a lot of signals from CloudWatch, for example. CloudWatch is sort of fairly basic. That's where all the signals come from, especially in all the AWS managed services we use. And we're also experimenting with a bunch of other things, especially the more recent or cutting-edge ones like Q. So we are playing around with Q to set agents for Q agents that will sort of set up monitors and alerts for you on your own. What has this led to? Right? So our efforts in observability and automation have already translated into concrete outcomes and significant business value. Our systems invoke literally millions of automated actions these days as a matter of routine. We managed to eliminate a lot of manual grunt work and significantly improve the quality of life for operators. And of course, the jewel in our ops crown, we've delivered an outage-free IPL. Right? And believe me, an IPL season is a beast. It takes a lot out of our team, and we could not have done it without building the observability muscle we have. So what's left to be done? A bunch of stuff, actually. Our Uber vision is that we build systems which are autonomous, where the computer figures what's going, if something goes wrong, the system figures out what's going wrong and fixes it. Right? And we're very bullish on newer technology like AI and ML and Gen AI in particular to help us get there. That's still a while off, though. And in the meantime, we still have to focus on the day-to-day operations excellence stuff that allows us to deliver uptime and performance every day. Right? And it's probably a good idea to end on a cricketing note. So there is a phrase we use in cricket, especially when a batsman, for example, has gone through a slump, but is basically a good batsman, which is that form is temporary, but class is permanent. And that's what we aspire to in our ops posture. Thank you.
Thank you, Amit. Wow, that is so fun. And obviously great to see the scale with which they operate because cricket is so popular. But as a separate tidbit for those of you, I'm a big cricket fan, really looking forward to next year's IPL. And my hometown team, I'm from Bangalore, the RCBs have never won. So go RCB. Next year, hopefully, is our time. Excuse me. So now let's move on to the third pillar of cloud operations. This would go. OK. So now that you have gathered all of this telemetry, question is, what do you do with it? You need scalability in order to store all of this raw data and telemetry. Second, you need a query engine, and you need to be able to index and analyze all of this data. It's like David alluded earlier, looking for a needle in a haystack, or using analytics to figure out how many needles are in a particular haystack. And with that, I'm running out of analogies, but you know what I mean. And then most importantly, you want to do this without the need for having to copy data from all of your different data sources. I think one of the hardest things is maintaining these ETL pipelines. So like I did earlier, before I walk you through all of the features, I'd like David to come back on stage and show us a demo of some of the features that we are launching in CloudWatch and OpenSearch Service. So take it away, David.
Thanks again, Nandini. So in the last demo, I had to navigate across my architecture to eventually land at the place where I could troubleshoot the problem. Other types of investigations have me start where I already think the problem is and drill deep down into the data from there. So for this demo, I had a new thing to investigate. A customer called customer support and said that they had a robot that they set a schedule for future actions, but when they went to look at the robot, it wasn't moving. It wasn't following the schedule, and that had evaporated from our system. So they no longer can see the schedule that they've created. This is a big problem. Let's figure out why it's happening. To investigate this, I'm going to use the new transaction search feature of CloudWatch. This lets me go back in time to see every customer interaction with us, to see how our service was performing. This analytics UI lets me analyze spans, which are essentially structured request logs that have all the details about every customer interaction through every part of our distributed system. So what I'm going to do is I'm going to find all of the interactions that this customer had with us by building up a query. So I'm building a query visually. I'm picking which service, the server, and I'm typing in the specific ID of the robot that the customer is having trouble with. So I run this query, and it's going to return me a bunch of spans. And these spans, just to have a bunch of information, I need to zoom in and understand more. These spans have a bunch of information that comes from places like OpenTelemetry auto instrumentation. It's coming from server frameworks, client frameworks. Or it's instrumentation that I've added myself because I'm going to need to use it when I do investigations, like which robot this request is for. So now I have an idea. I'm going to see if this customer just accidentally deleted their schedule by calling the delete API. After all, maybe somebody else in their household did that. So it turns out I run the query, and no, this is not what happened. They did not call the delete API. So now I need to follow another lead. So now I'm going to see, well, let's go back and look for when they created the schedule in the first place. But wait a minute. Hold on, David. This is going to require me to scan days or weeks or months of data. And that's going to go through a lot more data than just a small query. Thankfully, transaction spans are stored in CloudWatch logs. And we just released a new feature in CloudWatch logs that lets you define indexes on those logs. So I've defined a robot ID index. So the lookups are really quick when I just need to look for all of, even across a lot of time of data when I'm looking for a single robot. OK, so let's go back and find when they created this schedule. So I'll continue by running that query. Oh, yeah. I'll continue running the query to see then what happened. So I'm fetching the data, and that's going to return an interesting pattern. I see in the results the transaction span returned a 409 status code to the customer. Well, that's weird. That means HTTP conflict. We can click on the span, and now we can see that whole trace as it flowed through the system. You can see that it went from bot service to schedule service, and it had an error talking to DynamoDB for some reason. So that's where I need to focus my investigation now, is on the bot schedule interaction with DynamoDB. So I need to zoom in on that. Now, when I do this kind of zoom in, I'm looking at the application log to see what my application said in the debug or error warn info, those kinds of things. On the left, I have spans. Those are the spans that say how the service was performing during each request. On the right is the debug logs to say what my service was doing. So I need to join the two. I need to find all the spans that errored for this robot and get the application logs for every one of those interactions. But wait a minute, David. CloudWatch Logs doesn't support joins. Until now. So we have brought OpenSearch's query engine into CloudWatch Logs. So if I feel like writing queries in SQL, I can do that. And it brings the ability to do join and subquery. So I'm going to write that log that says, get me all of those spans matching those criteria, and for each of those, join with the application log, and now I have a bunch of stuff that's very useful. So here I can see from the interaction something strange. Our system sent the schedule to the robot, and then it tried to save it to the database, which failed. What the code should do is persist to the database before even interacting with the robot. OK, so we found the bug. Fantastic. But now we have another problem. How many other robots are messed up like this? How many other places is this happening that we need to go fix? So I need to run some more queries. Before I was analyzing specific robots, now I need to look across all of them. So to do this, I'm going to use just the CloudWatch Logs query syntax instead. I could write another one in SQL, but I just like switching tools sometimes. So I'm going to use Logs Insights QL. It doesn't really matter which one I'm using because it's querying the same underlying CloudWatch logs. It's using the same indexes. It's not copying data or doing any ETL. It's just querying the same data. So I'm going to query for all the robots that experience this error and count how often they happened. And so now I have it. I have my list of work. I have my work cut out for me because I have to go communicate with these customers and fix the robots. But I have everything I need to get started by doing that. Now, I just showed you a pretty powerful new analytics Opsitron. We just combined logs, spans, indexes, zero ETL, and OpenSearch all together into this new powerful Opsitron. And we used it to do two types of things. We dove directly into the data deep to find specific things that we were looking for, that needle in the haystack query. But we also did analytics to look across all of the interactions of all robots to find just the ones that that are the sign of what I need to fix. All of this was without having to copy the data across systems or switch tools. So I'll now hand it over to Nandini to kind of walk you through everything that I just showed you.
Thank you, David. All right, so as you can see, we're making it much easier for you to analyze performance issues and gather insights, as David showed you, from your data, no matter where the data resides. So just to walk through the features, you now have complete visibility into all of your application transaction spans so that you can quickly pinpoint the root cause that might be impacting your end users. Now, using application transaction spans in CloudWatch, you can track 100% of your application spans as logs. And the most important thing here is you no longer need to sample. You can just bring all of them as log data. And this, for example, think about it if you're on a customer support call, for instance. And now you can answer questions about your end user transaction for every single user, and you can tell what went wrong or why it did not behave the way you expected it to. This feature, once again, works with application signals right out of the box, no agent or anything required. Second, earlier on, I talked about the need for you to derive insights no matter where your data resides, which means you don't want to make copies. So starting today, CloudWatch provides you with easy way for you to collect all of the data, and you can transact and look at it no matter where your data resides. Okay, now moving on to the next one. You can also investigate your log data as David showed you. Whether your data is stored as CloudWatch logs or in OpenSearch, you can now interchangeably use both of them without needing to make copies of the log data. So no need to maintain any expensive pipelines, no need to copy your data, and most importantly, you can use this using either the CloudWatch query language, SQL, or PPL, and as David pointed out, now we have joins and nested aggregations, and I'm super excited for all of you to give that a try. On a related note, we've also launched Zero ETL for security analytics, enhanced security analytics, which brings together OpenSearch and Security Lake data. In fact, Chris Betts is going to be doing an innovation talk here at 3 p.m. today. So if you're interested, you can hear more about it in his talk. And finally, many customers have operational data that lives in either multiple managed clusters for OpenSearch or serverless collections, S3 buckets, CloudWatch logs, or other locations. Previously, in order to analyze the data, you had to have a single OpenSearch dashboard per data source, which meant you ended up with multiple data sources like this one. So you had one dashboard for each of them, for a managed collection, for serverless, et cetera. Now, our next generation analytics experience provides you with one unified view so that you can see all of your data, no matter what the data source is, you can see all of it in one single view. So we have covered a lot of ground today, and I want to recap. So we made it easy for you with a little cheat sheet here. So you feel free to take a picture of this one. It links you to all of the launches we talked about and gives you a lot more details, and there's a whole lot more information. I want to thank both Capital One and Dream 11 for being here and walking through how they leverage AWS. So let's recap. At a high level, part one, for your governance, we have launched enhanced node management capabilities in Systems Manager, as well as two preventative policies that we've launched. Second, in order to help you with your observability needs, CloudWatch now adds context to all your telemetry. We've added ability for you to monitor network flows, get database insights from Aurora databases, as well as enhanced observability for ECS. And for analytics, we now offer you an easy way for you to bring together data from both OpenSearch as well as CloudWatch. The features we are launching today are focused on bringing together CloudOps services in order to give you a more powerful experience. An experience that integrates all of our services so you don't have to copy data, maintain context, or maintain expensive ETL pipelines. So that you can focus on taking your business forward and leave the heavy lifting to us. And this vision, and most importantly, the partnership with all of you from whom we learned so much, is what inspires me, and I hope it inspires you to partner with us as we journey into the future of what is going to become the best, and already is, the future of cloud operations. So we've come to the end of the presentation. There's a lot to learn here this week. So I'm going to provide you with the wrong slide. List of curated cloud operation specific talks. These are just a handful of them. You can take a picture of these. They go into far more details on all of the features that we launched today here. And there's a whole lot more to see. And with that, thank you all. Please take the survey. Go explore, because there's so much to see here at re:Invent. Thank you.